Well, finally, after some technical difficulties, I have my recording stuff up working again. So I want to go ahead and get started with what we're going to be doing with the section on confidence intervals, which is chapter 6 with the notes. The notes online for chapter 6 are going to be way more than you need. I would use those for reference. I've already uploaded this set of notes that I'm speaking from up into the files on Teams, so you can access this. So what we're talking about in this section, we're going to talk about confidence intervals, we're going to talk about critical values, and we're going to talk about minimum sample sizes. And I'm going to have this correspond to the way the homework questions are coming at you. So the very first homework questions are confidence intervals around a mean when sigma, meaning the population standard deviation, is unknown. Is known. The population standard deviation is known, and we need to be able to differentiate between a sample standard deviation and a population standard deviation. So here's our guidelines. We verify that either S, the sample standard deviation, or sigma, the population standard deviation, is known. The sample is random, and either the population is normally distributed or N is greater than or equal to 30. We got to find our sample statistics, N and X. We find the critical value, which is Z or T. Now notice it's Z when we know the population standard deviation, and it's T when we don't know the population standard deviation. And this is going to correspond to a given confidence level, which is C. And we'll see what that is in just a minute. Sometimes that's abbreviated as CL, but we'll get there. I find the margin of error. Now, the formulas for this are kind of squirrely, and some of you may have already used them waiting for me to get this video, but I think when you see how this is done with Statcrunch, you're going to find it much more efficient. So anyway, I'm going to find the left and right endpoints and form the confidence interval. So here is the notation that we need. Some of this we already are familiar with, and some of it will be new. N is our number of sample values. We're familiar with that. Lowercase c, sometimes abbreviated as confidence level this way, is the confidence level. Mu is the population mean. X bar is the sample mean. Sigma, population standard deviation. S is the sample standard deviation. E, uppercase, is the margin of error. And then Z, subscript C, is the critical value when the population standard deviation is known, which is the Statcrunch normal calculator that we're familiar with. And we're going to be introduced to a new calculator called the student T, or the T calculator, and that's T subscript C. Those are critical. So how do we do these? And here's the thing. For this class, we're only going to work with confidence intervals around a mean and confidence intervals around a proportion. So we use a best point estimate and a margin of error to construct the interval. So essentially, we're going to be building things around either mu or p. So below, we're going to see the construction of a confidence interval for a mean. So we estimate them, we use X bar for the mean, right, and the margin of error. So to get the top limit, the top confidence limit, you take X bar and you add E. And to get the lower one, you get X bar minus E. And so what that looks like in a formula is here, and you'll see a couple of homework questions and a test questions where they actually give you the interval and they get you to identify the best point estimate of X bar or the margin of error of E. I don't know why the E has a lid on it. It doesn't need it. I need to fix that. Let's take care of that right now. We just need a capital E. We didn't need, there we go. And I am going to italicize that. Hang on a second. I thought I had this already, but apparently not. And now we can hide. There we go. All right, so let's look at a couple of examples. So the first example is they're going to give us our confidence interval. So we have a 95% confidence interval for the mean length of wait time in a hospital emergency room. It's 35 minutes, which is less than the mean, and the mean is less than 75 minutes. So I want to find from that the best point estimate and the best margin of error. Well, the best point estimate is X bar. That's another way of saying my sample mean. And the margin of error. So X bar, I take the 75, the upper one, add the lower one, divide by 2, I get 55 minutes. And then to find the margin of error, I take the upper limit, subtract the lower limit. That's going to give me 40. I divide by 2, that's 20 minutes. And so now if we go back, we see that if I take 35, the lower limit, and add 20 minutes, I get 55. So remember that a confidence interval is symmetric around the best point estimate. Now, here is the first homework question, and this is where we're going to use Statcrunch. But before we do that, I'm going to open Statcrunch, and I'm going to show everybody some things. Now, this will make more sense as we go through, but the tools that we use from Statcrunch for this section. All right, I've clicked stat, and you notice we have Z stats, T stats, proportion stats. Those three things right there, the only three things we need for this section. We're only going to be using one sample, whether it's Z stats, T stats, or proportion stats. Now, over here, and we'll go back to Z stats, most of the questions will be with a summary. We can find margins of error and sample sizes using the width sample size down here. We will not use the power sample size. And there's one question in the homework and one question on the test where you'll need to learn how to do this when you have the data rather than the summary. So that is the parts of Statcrunch that we will be using. And now for finding critical values, I want to go back to the calculators for a minute. And notice we have the normal calculator and the T calculator. So for the questions where you find critical values, this is what you'll use. You do not, I repeat, do not use the charts. There's no reason to for this test. I know there was some confusion on that, and I apologize for that from last time. So I know we're going to be doing a Z-stats problem for this first one, and this is the first problem from the homework. So I'm going to go ahead and open that here. One sample, and I know I have a summary. And I need to pull my question back up for a minute. Let's see if I can minimize this for a minute. So notice the information given. This is from mine. Remember, your numbers are going to be slightly different. But my confidence level was 0.98. X bar was 8.6. Let's see if I can pull this out of the way. The population, see, they tell me it's sigma. So I know that we know what the population standard deviation is because that's what this notation is. This sigma is the population standard, and n equals 40. And you'll see my solution is going to be n equals 8.49 and 8.71 for the top end. And there's how I put this up there. This is what you're doing with Statcrunch. This is what it looks like. And then I'm going to click compute, and I'm going to get this result right here. So let's go ahead and walk through that. I'm going to open Statcrunch. And I'm going to go stat, Z stats, one sample with a summary. I'm going to put my sample mean. Now remember, your number is going to be different. I'm going to put my standard deviation of 0.3. I'm going to put my sample size of 40. We're going to be using these same tools in the next section on hypothesis testing. I want to do a confidence interval right now, and I want to do it for a 98%. That's C. And when I click compute, you'll see over here I have a lower limit, and that's going to round to 8.49, rounded to two places, and an upper limit of 8.71. So now let's go ahead and pull our notes back up. And you notice I've done a screenshot of this, and that's the first question. And I think the second question is just like that. So at this point, hopefully this clears some things up. Again, I don't want you to get too bogged down in the notes, and don't get too bogged down in the viewing examples from Pearson, because you're going to find these are much more efficient and I think much easier to understand as we move through these with Statcrunch. So this is a start. Hopefully I have a second one of these up shortly.